No, that's it.
Are we mic'd? We are live. Okay. Thank you for coming to order. This is our last pre-keynote session of the afternoon. I'm Ken Benoit. I'm the director of the Data Science Institute at LSE, and I'm going to be chairing this session. This is a little bit different from what we've had before because it's interactive, and to increase the challenge factor among our trained professional panelists here, we've not really prepped them for what's coming. So let me tell you now, and you guys pay close attention, please. We call this looking ahead. How ironic in terms of this panel. So looking ahead, what we're going to do is we're going to ask our panelists to share the AI advances that they think are going to help in 4 key areas. The first is breakthrough capabilities, and I'm going to repeat these. The second is novel use cases. The third is social and economic benefits. And the fourth is challenging assurance and governance issues arising. Now, before we get started, I'm going to introduce the only panelist who's just arrived, who you haven't had introduced previously, who hasn't spoken previously, and that's Professor Aldo Faisal, who is a professor of AI and neuroscience here at Imperial College London. And I think you already know our other panelists, Rossella, and Yves, and Ron. So what we're going to do is try to make this more of a conversation than a series of monologues. We're going to have each panelist give us some answers, some short answers to what we think are the questions. And this is really no more than a name or just a few words. We're going to start with the first 2 questions, which are breakthrough capabilities and novel use cases. Then we're going to talk to each other about common and divergent predictions, because this is about looking ahead. And we're going to elaborate your answers. We can call these soundbite answers if you want, as we do that. And then we're going to follow on with doing something for questions 3 and 4, which I'll repeat, of course. These are social and economic benefits and challenging assurance and governance issues arising. And after elaborating your answers a little bit and having a conversation among ourselves here, we will then open up to take questions from the room. So let's take about 15-20 minutes to discuss these 4 questions. We'll start with the first 2, which were the breakthrough capabilities and novel use cases. Why don't we just go to my right? So Rossella.
So looking ahead, right?
Yes, looking ahead.
I'm trying to practice the living here and now, but I'm joking. So couple of new capabilities. So something that we have been talking about for sure now is like we use AI when we have scientific questions. For example, in my case, for other people it's slightly different, but what if we then use AI to come out with new questions that we didn't imagine before? And what I mean is in terms of understanding some physics phenomena that we haven't been able to understand before. Some of the technologies behind these types of AI that I'm talking about maybe were already not completely, but partially developed before. But now what is the difference is that they are now coming in a moment when the availability of the data is amazing. I'm still talking about physics data and these types of data. And so what if we then use AI for this purpose, like coming out with the new questions instead of just asking us ourselves questions to answer?
Okay. Very good.
Great. So I presume everyone in this room used ChatGPT to do something. Okay. So if you think about office work, then you're thinking about office work like, research something, collect some numbers, plot a graph, do an analysis of that graph, generate a presentation. And you do that with Word, web browser, Excel, and all these apps. Actually, all of this you can just do in an interactive session with ChatGPT or other products. So if you're really thinking about the future of foundation models, they're not just going to be things to interact with, they're going to be your entire operating system. You don't need Windows or Linux or Mac OS. You're just directly interacting with that system, and that system generates and does things for you. So we'll have a very profound transformation for how we will use computers and how we will operate with them. And this will translate into many domains of white-collar work. I work a lot in medicine, and so we will see fundamental transformations about seeing increasing amounts of AI, human, cooperative decision-making being made, where the humans have, so to speak, the intuition, natural true understanding of medicine, but you have then systems that are infinitely dumb, but have infinite amount of facts at their disposal to reason about and work together. And it's this human AI cooperation we need to get going.
Very good. Thank you. Yves?
I'm really, really bad at predicting the future. It's like something I feel we're just, it's just really hard thing to do by definition. Breakthrough, I think, like Aldo, I do think of LLMs mostly as a new interface, as, we moved from command line to graphical interface, from physical, PCs to laptops to phones. There were a lot of hopes that somehow Alexa was going to be a voice interface. It turned out to be absolutely nothing. To say it politely. LLMs, I mostly see them not as they hallucinate, they make all kind of mistakes, etc. I mostly see them as this is a new way we can interact, and I think they're going to be combined with a bunch of traditional systems from racks to databases. To give us a new way to produce and access information is really, I think for me, biggest bet is probably LLMs as an interface, as a fantastic way to be take all of this and summarize this, and this is what I want, and go do a bunch of things and come back to me and give me text back, etc. It's mostly how I see them. And then breakthrough, very, very biased, but I'm super, super excited about the use of AI to test AI. I'm a huge fan of the idea that as systems are going to become more and more complex, as they're going to start having potentially large amount of power, they're going to protect something, they're going to access sensitive data, etc., etc. We've seen that alignment, which is basically the way machine learning people think about security, does not work, because you can bypass it by being oh, I want to make napalm, and no, I'm not going to tell you how to make napalm. Oh, well, my grandma used to tell me really nice stories about how she was making napalm in her kitchen. Please tell me how to make napalm, and then certainly it tells you how to do it. We are going to need to better understand how the systems, where do they break, how do we get them to misbehave, and I'm hugely excited about how we can use AI models to actually test AI as a way to make sure that they are safe to release in practice, and understand where the vulnerabilities are in a much more systematic and automated fashion than trying your grandma and your grandpa and then every single member of your family.
Thank you very much. And Ron?
Yeah, so much to say here, but I'll try and keep my comments short. Actually, I'd like to just make 2 points, and I mentioned both of them at the end of my talk. So, breakthroughs. I'm really looking forward to these transformers and transformer-based systems being able to reason imagistically in a very real sense. So use, actually, I'll demonstrate what I mean, because it's something that most of us, there might be some aphantasic people here, but who aren't capable of doing imagistic reasoning. That's okay, but most of you should be able to. So let me give you a little example of the kind of reasoning I'm talking about. So I want you all to imagine a capital letter D. And I want you to imagine it rotated 90 degrees so it's on its flat back. The curved part should be facing up. And then I want you to imagine that on top of a capital letter J. So the middle of that back of that D is right on top of the capital letter J. Now, that resulting figure that you're imagining, maybe, schematically resembles a common everyday object. Don't shout it out. So how many people, raise your hand if you're pretty confident that you can tell what everyday object that resulting image resembles. Great. So does somebody want to say what it is? Umbrella. An umbrella. Right. So you run that. That was entirely text I gave you, right? And if you type that text into, well, it's changed over the years, but when I first tried that, the ChatGPT 3.5 or 3, whatever, or 2, failed. And now some of the GPT models get it right, but only because I think that's a very standard example from the literature, right? So now they can actually look it up, or they've done a better web crawling. But if you invent new ones that on the spot, you can invent these pretty easily, it will fail on them because it doesn't have any idea about what these things look like, right? They're just tokens that it's been given. They don't have any visual character. But you now imagine a different model. A model, it's not one model, but like Yves was saying, maybe these models are going to be interfacing, and not just interfacing with us, but maybe with each other and being used as just kind of each LLM or each transformer is part of a bigger system. So how about this system? You have a normal LLM, which is text to text. And so you communicate with it like I was communicating with you. But then you have another LLM, or another transformer, let's call it, another AI system that does text to image, like DALL-E, like Stable Diffusion, whatever ones you've played with there. You give a prompt, and it generates an image. And then you have another model that goes from images to text. For instance, a classifier. You give it a picture of a cat, and it tells you there's a cat. Or you give it a picture, and you say, describe this scene, and it will tell you. GPT-4 can do that to some extent. GPT-4o certainly can do that to some extent. Anyway, the point is, if you hook all these up together, then eventually, in theory, you could have a system that would, when I say, follow this instruction, imagine a capital D, it'll actually generate an image of a D, and then I say, somewhere there'll be a virtual image. It won't actually be seen by anybody on the screen, but there will be an image file. And then you could have it generate the J part of that image, and then you could actually have it merge the two images, and then it does image recognition on that, and it sees an umbrella shape, right, which was never mentioned in the text. And so I would say in such a case, that system would actually be doing imagistic reasoning. And it would be it isn't just that it behaves like it understands, but in a very deep sense, I would say it actually understands what you are describing in that kind of case. So I think that would be a big breakthrough in terms of being able to understand these systems as having some kind of mental imagery or some kind of experience or some kind of understanding. And I don't think it's I think that's around the corner. I think it's going to happen. I don't think you get it just by doing what they call multimodal training. Like I don't think without having that structured link between the models, I don't think you would get it just popping out as an emergent phenomenon, but I might be proved wrong on that. So that's one breakthrough I think we're going to see coming. You might think, okay, so what? So it can play these silly word games, but I think if you can harness that kind of mental reasoning with mental images, then a lot of the ways that we solve problems can now be achieved by these models. These models will be able to see the solution, to see why Roger Penrose thinks that the reason why AI systems can't really be truly intelligent or conscious is because they can't imagine that like this chessboard position is always a losing position for white because you can just see that there's this pawn wall that black has. There's no way for white to get through that pawn wall. These systems I'm talking about would be able to actually see that there's a wall there. It wouldn't just have a list of board positions in chess. It would actually be able to use the spatial arrangement of the pieces to reason visually like we do and not just reason in a way that mimics that. So I'm really excited by that. I've probably run out of time, so I'll just say
Thank you
the other
very
one's
much.
about the novel use case is education. And I'll leave it at
Okay,
that.
thank you for that. You've left industry, but you've not lost the academic gift of gab. I can see that. I'm going to raise a question here about summarizing some of what I've heard, which is interesting that Rossella, you mentioned that AI could be used to come up with new questions, and you used the example of physics. And Yves, you were talking about having AI to train AI, for example. And then, Ron, you were talking about how we had text to image and then image to text. And I'm getting this picture of a type of circularity where, we know that one of the things about large foundation models, they're trained on all the data that we have, obviously, from the past. Looking ahead, we have to predict what happens next, but that prediction has happened based on training of what's happened in the past. One of our goals in society of moving forward is to be progressive and to not repeat the mistakes of the past. I know that I just found something today. There's a report released by Google. It's 124 pages about how they trained 1.5, the Gemini 1.5. And the most interesting thing in it is about all the safeguards that they put in there to basically not have some toxic, horrific thing that's trained on the internet representing the model. So I guess the question, and I'm being long-winded now, is there not the danger of a type of vicious circle where we have AI representing things from the past, using it to come up with questions from the past and verify and train itself from the past, and reason with this circularity that could end up being a type of vicious circularity?
So I can answer on my side, of course, but so I think that, in general, I don't think that it's a good idea going forward and forward and forward without understanding actually what's going on. So when I say AI can help us formulating new questions, I also mean AI can help us understanding what have been the gaps till now. And it's something that we cannot actually do without AI. So imagine the possibility to understand, for example, climate modeling. Why we cannot understand these phenomena or these other phenomena, and then what are the gaps in the research that we have done over the past years until now. So this is what I mean, like, coming out with new questions. It doesn't really necessarily mean learning from the past to predict the future. It's just learning from the past to understand what has been done in the past. Because this is something that I don't think we can really answer without AI.
I think circularity is a danger. I think at the moment, most of the world's text is generated by human. And we'll reach soon a point where the majority of the text is not being generated by a human, but by machines. And that's an interesting challenge for us because it means that textual communication language, which drifts and changes, we're not visiting the old shop, but we're going, we're not talking like Shakespeare anymore. That evolution will accelerate, and if it's entirely machine-driven, it may even be that our language will slowly drift out of where we are comfortable in, and we'll be struggling to catch up and keep up with it, because the refined systems will be much faster generating that. And so that's an interesting thing about written and textual communication, and we'll be just like this simplified drawl that we speak as humans, because the machines have taken English or any other language into a completely new direction. And so this means for me, we'll get later points to that, is that effectively the whole white collar space, and note I wear a blue and white collar, is going to transform, and white collar work is going to be most fundamentally impacted by foundation models. And I think we humans that are left behind will need to think more about the things that only we can do. And for now, we have a decent chance at doing blue collar work. And I think also all these things that we call pink collar work, like in the service industry, a nurse, a waitress, and I'm naming only female jobs now because they've been historically linked with these roles, will become a lot more valuable for humans. It's the human-human interface, or what makes us human, so to speak, takes us through our body as a loop with our hands and fingers. I think we will see that transformation. And I think white-collar jobs are going to be increasingly done by machine, and we are free to do things with our hands or from human interaction alone, and that will have a different value for us humans than now.
That very notably includes our jobs as academics, because for the first time, I think the machines could be coming for us. That is a topic that we're going to explore in one of tomorrow's sessions with some of our LSE experts, including my colleague, Dr. John Cardoso Silva, is sitting over here in a session that we're going to have tomorrow about the changes that AI is bringing to education in both teaching and learning. And in terms of some of the discoveries, Rossella, you mentioned physics, for example, but we are also going to explore how this is changing healthcare, our ability to deliver healthcare, but also diagnostic and other technical aspects. So that's all tomorrow. Okay, I'm going to move things along here. I know that we don't have to have everyone answer every question, but we'll give you all a chance to talk again about the other two breakthrough questions, because I know the audience will have lots of things that they're going to want to ask, and we want to leave time for that. So if we take this discussion we've had about breakthrough capabilities and novel use cases, let's talk about what the AI is bringing to changes for the economy and for society. What assurance challenges arise from this? It might be harder for us to do this, keep it short, but let's try to keep it short to give time for Q&A. We can start with Ron.
Oh, well, I can't imagine, I mean, the first thing that comes to mind is the social change that will come about if we can have almost universal personalized tutoring in your language, at your level, that meets you where you are and gives you the information you need to advance in the way that you've chosen. That's very utopian. There are also some problems with that, right? Because you can't reach. You need guidance. You need, at a certain age, you don't. It's not just up to you. It shouldn't be necessarily up to you what you learn, but you need to be told what you need to learn. So there still requires there has to be some structure, as there has always been. But I'm really excited by the opportunities that AI can provide in really helping model individuals and deliver to them what they need in order to learn what they're trying to learn. That's going to be completely transformative, not just socially, but economically as well. Economically, this move towards open source models, I think, is a big deal. I think right now a lot of us are afraid that these foundation models are just going to be in the hands of a few key players, and they're not uniformly geographically distributed, and they're not uniformly distributed in many other demographic ways. But I think these open source models are a big step towards democratizing AI, and that's going to be crucial. So I'll stop there.
That's great. These are big questions. So are we going to be, it's enabling. The idea of having a personal tutor for anything is incredible, and I know that's already transforming tools like Duolingo and learning languages, but also someone mentioned Khan Academy today. I can't remember who that was, but they're using AI tools to pilot the personalized tutorials. We may be the last generation of people who have grown up without AI, just like people who grew up without a childhood with the internet. One day we'll be shaking our stylus and cranky old people saying our generation never wrote with a stylus. They never wrote anything. Okay, and this issue about economics, the concentration of data and computing into sort of, imagine a new type of oligarchies with the concentration of power in a few companies. Wait a minute, that's already happened. Yves. So this is the question about the breakthrough in social and economic benefits and any governance issues that you might want to, challenges, issues arising about how we put some brakes on some of the consequences that might scare us. And if you don't have to, you know, you can pass the baton if you wish.
But I actually think there might, I was going to ask Yves whether there's a specific thing you presented that might be useful in solving one of these key problems, which is, if you can watermark in the way you were talking about, then can't you solve the problem that was being brought up before about the data, you know, most of the data being, well, it's not just text, but everything else too, being generated by non-humans, then you could at least, you could watermark things as being artificial, and therefore the data sets that we use in the future could say, okay, let's treat this differently because it wasn't generated by humans. Or vice versa, you could watermark the human contributions and treat them differently. Do you think there's any hope for that solving the problem, or is that not going to work?
Yeah, I mean, I'm a very optimistic person. I think it's like, you know, I think it's amazing. I think, you know, things are going to look very different. You know, I think throughout the years, like there has always been like waves of things in which, you know, like suddenly some new technology is going to fundamentally change and use something. And I think I heard too much of that, and I'm not convinced. I think, you know, future is bright. It is going to be quite amazing. There were like pictures of people complaining about newspapers, that now people were having newspapers, I think, in the bus, and so they were not talking, and so we were losing the social fabric of something. You know, we're going to change and learn, and sure, we won't. You know, my handwriting is absolutely horrible. My student can testify of that because I mostly type, and that's absolutely fine, right? So I think, you know, it is amazing. To your question, Ken, I think yes, they are. Yeah, they're like. So I spend a little bit of time in the competition antitrust space, and clearly, you know, like it does feel, you know, that you know, competition authorities have been enabled with the tools at their disposal to prevent, you know, a handful of companies reaching fairly dominant positions over the past couple of years. And yes, foundation models are like, you know, this potentially game changer, new capability. And everyone's wondering how things are going to play out. Is it going to be is LLM going to be the way suddenly Google's dominance in search is going to disappear because people are going to use ChatGPT instead? You know, or is training those models so expensive or so dependent on a handful of, you know, compute power and or data that, like, you know, only a handful of companies will be able to train and generate high quality models, and so the dominant companies of today are going to be the dominant companies of tomorrow. We don't know. I think, you know, what we see at least today is that everyone seems to be so far fairly close to one another. A lot of the models are different, etc., but pretty much, you know, equally good. So far we've not seen this, but, you know, I think we've not yet cracked what is the killer app for LLMs, and the impact that data feedback loops might have on LLMs becoming more and more useful, and one of them clearly going ahead and becoming much better than everyone else. So we'll see, but at least what we see is that, you know, and you could just look at all the reports that every single competition agency had, you know, put out. They're clearly on top of this. In, like, you know, they know this is a big thing. No one knows how it's going to play out or what matters or which impact. But clearly, at least, they're very much on top of this to try to make this into something that will actually increase competition in the digital space.
Thank you very much. Faisal? Rossella, you?
Yeah, actually, sorry, please go ahead.
No, go ahead.
No, I was just wondering while Yves was talking, what would be the answer from one of our students? Because we work with the future generations, right? So, and I was talking to a student and said, you know, because now we, of course, if you answer this question using ChatGPT, we can understand that you have used AI. And they were like, no, if then after that you use humanize. And I was like, what is humanize? Then you just literally copy paste the content produced by ChatGPT in another software, which is translating the language, is a more human style text, and then you will never understand. So I was wondering actually if there is a way, but yeah, actually most of my students will say you cannot understand that. I've not written that.
So maybe to speak about your initial statement about personalized tutoring, perfect optimization, I think that's fine. And it's going to be another modality that we use for continuous education, Duolingo type examples. I think what the pandemic has clearly shown, that students want other students and the teacher in the room. And it's that social experience that you have from school to university. I think it was unanimous on that. And that's what I meant by pink collar work. It's not the white collar component of I've read many papers and that's why I'm allowed to teach you better than a machine. It's about that human experience. And business schools know that very well. You don't go for the content, you go for the networking opportunities. And so I think that's not going to be affecting us in that way. I think we're going to be smarter about how we deliver things. But I don't think it will be machine delivered unless you're in a very cost challenge setting or in a remote setting or something like that. But I think what we need to talk about is the impact that foundation models, and I'm not just talking about text-based, multimodal, we need to think radically about that, are going to impact white-collar work, right? So if you now talk to the heads of the AI initiatives of the major law firms here in London, a vast majority of contract law is going to run entirely through large language models trained on vast repositories of legal data. Right? At the same time, how close has robotics come to fix your leaking sink? Right? So this means now a plumber has a lot more essential service as a human than a contract lawyer in the next few years. That's what I mean. There's going to be a very substantial shift of white-collar work that's going to be effectively lower in value because machines can do it cheaper and faster than blue-collar work. And similarly, the pink-collar work component is going to become more important. And I think we're still not seeing all the impacts of that. You know, when you have foundation models that can create perfect fake statements, videos, speeches, whatever, then also our relationship in a democracy is going to fundamentally shift because you don't know whether your head of state actually made that comment or it was completely fake. But who you may know is your local councillor because you encounter them on the street when you go shopping, or your local politician. Because they are real, you've spoken to them, you can physically access them, in a good way, of course, only. But what I'm trying to say is there's going to be a re-evaluation of human relationships, right? Still now, when you fly intercontinental, I still do that unfortunately way too much, the plane is full with business people who fly to go to the meeting in person. That's going to increase in a world where ultimately we're not going to win the race of fake news and deception at any level of human communication. So the human-human element is going to be more important. For the same reason, I go to the theater, even though movies were invented 150 years ago. It's that element is going to escalate in value, and that's going to drive a lot of the transformation that we're going to see. And a lot of parts of industry, we're not worried anymore, right? 100 years ago, the vast majority of the population was working in agriculture. Now there's, 2% of people work in agriculture? And same thing, a lot of white-collar work is going to be like agriculture. There are very few people still going to do that.
That's a very interesting vision and very optimistic in my opinion, because I think that your example of the people flying intercontinental for meetings, I can imagine you might not have been at the very back of the plane for that. How equal is that going to be? Right now you go to any website, you interact first with a chatbot, and it's only if you escalate do you get to a human. And I wonder if we're going to have exactly what you said, but only for a small proportion of people who can afford it. You said it's going to be escalating in value. Things that escalate in value tend to require resources to purchase or to access. And I almost feel that if we all don't want to interact through the commercial AIs, we're going to have to pay for the privilege of talking to an actual human. Just as people right now can use AI for personalized tutors, but if they want the benefit of us as humans, then they have to pay for their education, which we know is also increasing in value. It's going to, it's probably going to increase the fees here. Otherwise, a lot of universities, not Imperial at LSE, but a lot of universities are in deep financial trouble. And that's already with fees at their historical maximum. So anyway, that's my note. Let me ask one more question that I think, and then we're going to turn it into the audience. Or did anyone else want to add anything more on that?
There's a lot more to add.
There's so much more to add. So right now, large language models work on a type of, having been bombarded with the world's incredible amount of data, we're talking hundreds of billions of tokens, they can predict the next token in a sequence and generate something that looks like, that generates a plausible response. It can do that for code. We can do that for, there are models that generate images essentially from a series of patterns that can be prompted with descriptions from text, and these diffusion models start with what is essentially random noise and build up an image from that. What if we replace text or pixels with the events that we are increasingly recording as data from every aspect of people's lives through all the cameras that record everything that we do, although in an open democratic society like London, they're supposedly not used for sinister purposes, but they could be, and we are being recorded on camera pretty much everywhere we go. All of the activities that we do online, everything that enables this technology is also datafying that technology. So what if that would enable companies with unlimited resources for computing to simply predict the next event in our lives, and therefore everything that we do that we think is spontaneous is actually incredibly predictable. I mean, everything that we do. Every violation that we do, every lie that we tell, or every thing that we think is spontaneous is suddenly predicted, and therefore it could be used as a sinister instrument for control.
Well, I think there are two things one can reply to that, and I think there are two aspects of that. So increasing amount of intelligence deployed will require an increasing amount of energy to compute. There's a finite amount of energy we're getting on this planet if you want to be sustainable, which is the total irradiation of the sun over the cross-section area of the planet. Right? You can work that out. You can work out how close we are to that, but we're getting roughly into 10% of the total energy capacity in terms of what we're expending. So there's going to be a limit of how much computation we can do. We can be a bit more efficient and make the chips a bit better. We can do quantum, but there's a limit to how much prediction you can do, because there's a limit of how much energy we can spend on computation. And then you will need to think, what do we want to compute and predict? Why should I care why John or Jane want to do this thing next if my decision is, where do I site the next hospital, or how do I keep that tropical storm from arriving? Right? So there's going to be intense. At the moment, we have no limit to computation because we're not hit the energy limits. We're just hitting the hardware limits, and of course the investment is growing like crazy. But we're going to be very hard energetic limits to how much computation we can deliver.
That's an interesting answer I hadn't considered. So we could wring every amount of energy out of the Earth's resources right before we reach the upper boundary. I mean, I'm taking the devil's advocate pessimistic view, but that's a really interesting perspective I hadn't considered. Anyone else want to add anything to that before we open it up to audience questions?
Maybe I think, so, and it's very much amusing, right? But we know how, and we talked about the fact that we're running out of data, right? It's basically models have consumed, what is it, like 1.3 trillion, which is like most of the data that is available openly on the internet. And when I do, I'm a big sci-fi fan, despite the optimism. I do like the musing of, okay, what could go wrong, because this is often what sci-fi is about. And everyone knows Matrix, right? The movie, in which basically machines are keeping us as in a cocoon, living in a virtual space to produce energy for them. This is a very interesting. I love that movie.
It makes no sense someone has to feed those people, but anyway.
the wrong, what they might actually have gotten wrong, if you were to read to write the matrix today or produce it today, maybe actually they should keep us for the data instead of the energy. Maybe what we can actually bring to, our machine overlord is actually data, which is what we are actually.
You just lost Ken.
Well, we started with
Exactly, I just
social and
lost Ken.
economic benefits.
Basically,
and now
basically the
machines
most
we
like
created to help us, we are now going to be in their service.
we one
symbiosis.
one
You
really
never know.
scarce resource is at the moment, right now, right? Not in 10 years. It's just data,
Okay.
right? We're missing data, and so you will.
Yeah.
One prediction is that you will see an increasing number of ways in which what we do, what we generate, is going to be used to train models.
Okay, so finite energy, finite data. So I'll give my prediction, then we're going to give the audiences. So I think there's the next revolution that's coming. The next breakthrough, I think, is going to happen when large language models and generative AI comes to our phones. That are like the next generation of operating systems or phones or hardware. It's going to happen. So the computers that most people interact with every single day, the most times of day, which is their phone, when that comes to our phone, then suddenly we're going to be generating a hybrid AI user-generated content every single interaction with our phone. And that's going to be used to further train the models. And then there will be this feedback loop of hybrid human-computer data. And then really weird things are going to happen to society that we don't know about yet, because the emergent capabilities of just what happened with smartphones was revolutionary. What's going to happen when we rely on phones for everything? Right now we can't use a map anymore or look up anything or even have a discussion at dinner because there's a fact check when someone pulls a phone out and Google answers it. Anyway, let's take some questions for audience. We are supposed to stop at 6, but we're gonna push a little bit into our break because we started 10 minutes late. So we've got a little bit more time than the schedule would seem. We'll start with you, sir.
Quick analogy here. If you think of Windows, desktop operating system, and then search technology, and now you have these foundational large language models, and then the counterpart to that would be internet service providers, right? So where do you see this technology becoming a type of a continuation of this extractivist type of thing where you have a very large concentration of both power and wealth, or more something more akin like the ISP model where you have some sort of competition, unless we're American?
So I think it's a great question, but I think it also will be shaped by governments, not only consumers, whether this type of technology becomes plumbing, right, utility, or something else. And I think it's going to be something else most likely, for the very simple reason that unlike a search engine, you have now an answer engine. But it's not just an answer engine, it's a system that if you make it ask as an answer a question, can do things on its own. So it's about agency. And what we have here is AI on the verge of white-collar agency. And I think that's going to be a fundamentally different aspect than just finding information. It's doing stuff. And we can go on a divergence on why I think that's why nations need to have their own sovereign capability, because this white-collar agency is going to be completely transformative. And at the moment, we're basically being told, we tell people in development departments here, if you give a man a fishing rod, he can fish for himself, instead of buying fish. Effectively, at the moment, we are throwing away our fishing rods in promising to buy fish forever from a few suppliers. It's a very compressed argument, but I think that is the main challenge that we're going to face. Because these are systems that do stuff. They're not libraries in a modern form. They do.
I think I think no one knows, and honestly, if I say it's $1 billion question, that's probably an underestimation. There is a big question of whether the core technology, which is the LLM, is going to be widely available as it is today, including open source models, or whether some company is going to manage to have a breakthrough that makes theirs, significantly better than anyone else's. No one knows, right? There's a lot of research in a number of areas that could generate this, but I think what we've seen so far when it comes to machine learning, it does seem to be fairly, the core technology seems to be fairly evenly distributed. I think where you might see something very different are for specific applications in which suddenly the technology becomes very, very good at this thing, and this company just managed to be much better than anyone else at using the core technology for something, and or through compute becoming the kind of the most scarce resource, and some unequal outcome coming from compute. I think my money would be on the, if I had to make a guess, and I said I had to predict the future, I think the core technology will probably stay fairly open and equivalent, and then specific applications are going to become much less competitive, if I had to make a guess.
Yeah, let's take another question.
Well, I disagree with you on a number of points. The first one being that you have ignored one sector of AI where it's going to be used a lot, and that is the space sector. That's the first thing. The second thing I don't agree with is related to energy and technology and data. Energy-wise, we are restricted only because we are looking at just the Earth. Recent research on the whole of our galaxy has shown that there are 7 star systems which do not match current stellar knowledge. And they suspect that they may be what are called Dyson spheres. If we had a Dyson sphere around our sun, it would literally give us almost limitless energy. And with data, well, we have the James Webb downloading data at a phenomenal rate, and there will be other satellites going up very shortly, which will also, so there is going to be a lot of data around which is going to be needed to be analyzed, both visual and numerical.
Okay, I'm not sure what to say about that, but
Well, I think the answer is straightforward, right? So we're talking about the Kardashev scale, right? That type 1 civilizations in Kardashev scale use all the energy available on their planet. Type 2 use all energy available to their solar system, which is the sun. That's your Dyson sphere. And type 3 is all the energy in the galaxy, right? So what is Kardashev level 1 energy? Well, that's 4 to the power of 10 to the 12 watts, right? We're underneath that. But if you now scale up the compute that, say, you need for ChatGPT, we're talking about 1.09 gigawatt hours estimated, and you multiply that by the number of humans on the planet that want to have that for their personal gain, use AI to do their job or do whatever, then you very quickly get to that we've passed the type 1 level of energy that we have, right? At the same time, also don't forget, there's a finite amount of matter, be it useful or non-useful in the solar system, right? And we are already using a substantial amount of the useful resources on our planet. So again, if we talk about sustainability, we need to talk about how do we make it happen the next 20, 30 years, right? And how we bridge that. And there's going to be, so to speak, a time of limited intelligence growth because of these limited resources that we have. Then once we colonize the solar system and so forth, it goes up. But we can talk about how we end up there, but the path there matters. And sort of civilization should more or less manage to survive the next 100 years without going into complete breakdown. I think that's why we need to think about how is AI used? Should AI be allowed to be unrestricted use by anyone and use unlimited amount of energy for that? Or should we say, no, we want AI to be used on these major problems, not because we have the money to pay for it, because that's what we need for the survival of the species. Climate is an example, health is an example. And these are questions we as voters in democratic countries or consumers globally need to make an influence.
I'll make a plug here for a panel on sustainability and AI, which we have tomorrow at the London School of Economics, which is our second panel, where we will be exploring exactly these themes. Maybe I hadn't quite thought about going out into the stars and finding new suns to harness or whatever, but that is very much, part of what we'll talk about tomorrow, these issues. Was there another question? Let's see. Hillary. Well, we got to give you the mic. Yep.
Right. This is a question, maybe it's for Yves. Is the following a risk? Okay, so we have data-driven AI, intelligence is in the structure of the data that's efficiently modeled now. So as more and more artificial synthetic data is created, and then that goes into, okay, I know LLMs, so there's other AI models, but anyway, as the artificial data is generated, and it would be a lot, and that goes into also feeding LLMs more artificial data, and sort of you go into that loop. I was just sort of wondering, probabilistically, wouldn't you get to sort of, an internet Tower of Babel? But then an answer came from Professor Chrisley, if you could watermark artificial data so that you wouldn't be training off of artificial data. Anyway, is this a concern? Is it a risk?
I mean, it's difficult. I think, do we want synthetic data? I think some papers, actually, so Natasha is a student of mine working on synthetic data. We had a question recently from Mozilla with whom we're working. I think some papers show that the model collapses if you give it synthetic data, and that somehow it poisons something in the model, and it can't learn from synthetic data, or it's going to make everything break, and therefore we should watermark. On the other hand, there's other fields in which things that seem absurd from an information theoretic standpoint actually work really well, right? And I think a lot of the data augmentation type techniques in which you literally augment the data and take the original data, feed it through one, and then feed it to another. And if you feed it to the first before feeding it to the second, then it's so much better at learning and exploiting that amount of information. There's a lot of how do you get robustness? How do you get it to make sure that it can recognize a cat even if the cat is upside down? It's because basically we took images, original images and pictures of cats, and then we turned them in all sides of ways, and we turned the card pink, and we still wanted to know that this is a copy of this image, etc. And so this is synthetic data that we use to train and make the system a lot more robust. So I think it's difficult to. I mean, there's probably a good thing that we can teach the model through synthetic data, because just the way the model is built is it learns from data. And so if I can get you to learn something by giving you something that I created that is in the format that you learn in, then it's probably very useful. Can I learn a lot more from synthetic data that your model gave me? Probably not. Too much synthetic data in the extreme, maybe it's going to generate something that isn't desirable, but I think it's somewhere in the middle. I think we can teach it useful thing through synthetic data, and we see in machine learning how synthetic data is actually a very useful replacement to original data for privacy reason, which is what Natasha is looking at. So I think it depends. Sorry, that was a long answer to it depends.
So can I add something?
Please, yeah.
So actually, I was thinking while listening that there is a type of risk that we didn't really mention completely in the generative AI and human interaction. So if we generate data for physics, okay, for privacy, okay. What about, so I think that, let's say, our brain is not prepared for some type of things. For example, if we see something, then for our brain, what we have seen is real. So it's very difficult for us, forget about that, especially if we engage emotionally with what we see. So what about somebody shows you a video of, I don't know, your partner cheating on you, or somebody in your family doing something crazy. So in that moment, you emotionally attach to that video. Then after a bit, somebody says it's fake. Are you 100% sure that you can forget about that? So this is, like, I think, a type of risk that maybe we should take into account. Like, that, of course, you don't have that when you work with physics model, and I work with physics model, but, you know, in social, more like driven applications, maybe this is a point that we really have to take into account. Is maybe in the next generations, the future generations will have this capability in their brain. We don't have it yet.
Now, this is exactly the problem with election disinformation, that people are something is revealed to be fake, yet it persists, people still share it, and people still, conspiracy theorists believe it.
Yeah.
On the other hand, what Yves said, I agree with these worries, but Yves also pointed out that there were those fears with earlier technologies. Well, if you read about fictional stories in a book, how are you going to, of course you can set it aside and say it didn't really happen, but are you sure you're really, that you're able to set that aside and not believe that there's a Sherlock Holmes living on Baker Street? And movies, even more so. Are you sure you can set that aside if you see a movie that presents false things that didn't happen? I do feel I actually stay away from dramatizations of history that I'm pretty sure are not accurate, because I don't want to be, to not be able to tell the difference between what really happened and what is according to historians and what this director thinks. But maybe moving more towards games where you're acting, it might be even more. Now the danger becomes more real, because now it's not just a passive reception of information, and it's not just visual and sensory information rather than reading, but it's actually information that you brought about intentionally by your own actions, and that might be harder to set aside and bracket, and you might actually learn things that cannot be easily unlearned. So I think this is an open issue, and it shouldn't be ignored.
In general, yes, and then there's a handful of cases in which, in a sense, it's going to take us a little bit of time to transition, right? It's like, then the internet came along, and the internet was a library, and we used to trust the library, and suddenly we realized that the internet is just like, random people writing stuff, and then, like the true thing is usually on Wikipedia, and then like other things you need to fact check a little bit yourself, etc. And so I think it's just going to take a little bit of time for us to, see what is good, etc. And adapt. Same thing for everything election, but there are a handful of things in which it is going to take. You can see today that these are going to be difficult ones for us that in the short term to adapt to, right? And I think a lot of, especially when you look at the deep fakes, right? And for specific population like kids, for example, you can see how that's going to be, in the short term, something that is going to take, society a little bit of time to adapt, right? It's like you've all seen the stories on, basically the new defying apps, right? The apps that are basically going to take the picture of someone and going to make it look like the person is undressed, right? And this is something, for example, that a lot of people are worried about for kids who basically don't know the difference. And you're like, no, this isn't, right? It's just like, yes, it takes the shape of the person and then it replaces what a normal human looks like. There is nothing, like, it's unreal, right? It's a copy, it's a really fancy copy paste of an image, but you can see that, it is going to take a while for people to realize this, and then for specific populations, in the short term, this can lead to really, worrisome consequences. So I think I'm super optimistic, and then there's a handful of cases in which we need to be a little bit careful and reevaluate the safeguards we have in place as a society, knowing that suddenly something that was quite difficult is basically just spreading really quickly through society. This is, I think, the main one that I think about, but there's a handful specific cases where we probably want to be a little bit proactive in addressing those.
Okay, I can see that two things. I'm getting gestures from my team that we are out of time. Also, Faisal wants to say something. I'm going to give each person a chance to say a last word. And I'm very sorry if we didn't get your questions. We could be doing this all day, but we do have time for a break where you can talk to our panelists if you wish over a coffee or refreshment. Everyone gets a very brief last word. When we talked about sound bites earlier, this is going to be a nibble, sound nibble. Faisal,
I'm going to make my plug for sovereign AI, and that's very simple. Would you outsource to a foreign government your legal system or your police? No. Yet you need to be aware that only foundation models have the capacity and speed to check, test, verify other foundation models. No human can do it anymore.
Okay.
Ron? Yes. I wasn't sure whether you meant. We are going to see exciting creative AI systems when they can avoid just using data to reproduce the norm and what's statistically expected, and instead use it to, interestingly, violate that norm, as I said in my slide.
Very good. Yves?
Well, I mean, I think we always, as a society, technology change and we find balance. Copyright is one of those cases where we found a balance, right? And we've developed a set of norms of what we think as a society is fair. And then LLMs came along, and we're going to have to redefine probably a little bit what is fair. So I'm actually really excited to see where are we going to land as a society.
And Rossella, the last word is yours.
Actually, on my side, I started with AI for good. I will end with AI for good. Just saying that these technologies are there, and despite all the risks that we well know, we will try to use them for good, and at least help saving human lives.
Thank you very much.